Okay, everyone. So this is your Unit 2 Radiation and Nuclear Power Study Guide key. So I'm kind of going over the answers for your study guide and give you a few tips for the test. So number one, just ask you to make a chart to compare and contrast beta, gamma, and alpha radiation. And it kind of left it open into the things that you want to include in your table, but these are the types of things that I would have included. What they are made up of, their charge, and their mass. I also included the symbols off to the side. I think that the charge and the mass are extremely important, and knowing that an alpha particle is made up of 2 protons and 2 neutrons helps you understand why the mass is what it is, so as well as the charge. For number 2, what happens to any element that undergoes alpha or beta decay? Well, if an alpha particle is 2 protons leaving, that means that you have a change in atomic number. And when you have beta radiation, that means that a neutron within the nucleus has split into a proton and an electron. And since a beta particle is that electron, that means the electron is leaving while the proton is staying behind. So in either case, you have a change in atomic number, which makes your element become a new element. So any change in atomic number changes the identity of your element. So alpha or beta decay always results in a new element. And then number 3, what is an isotope? We've talked about this several times, but it comes up a lot in radiation, so it's going to be on the test again. Atoms of the same element with different numbers of neutrons, which causes them to have different mass numbers. Number 4, isotopes of the same element have different masses, but their atomic number stays the same. Why? Because they're the same element. That pretty much sums it up. If they're the same element, they have to have the same number of protons, which makes their atomic number the same. Number 5, how does mass number change with each type of radiation? For alpha, your mass is going to decrease by 4 because you are losing 2 protons and 2 neutrons, all of which have a mass of 1. For beta, there's going to be no change in the mass. The only thing that's leaving is an electron, which has an extremely, extremely small mass, not even close to 1, so it's not going to make your overall mass change. Gamma radiation is energy, that's all. There's no mass whatsoever, not even the mass of an electron, so there's going to be no change for that either. So now we're just identifying these different facts, really, as either alpha, beta, or gamma radiation. If it's nuclear decay with no mass and no charge, the only one that could be is gamma, because beta has a charge of -1. The reason that beta radiation has a charge of -1 is that it is an electron, so that has to be beta. And then our least penetrating nuclear decay, or in other words, the one that's easiest to stop, is alpha, because it's the largest, has the most mass. The most damaging nuclear decay to the human body is the one that has no mass, the one that's hardest to stop, which would be gamma. Nuclear decay that can be stopped by skin or paper, again, has to be alpha. And then nuclear decay that can be stopped by aluminum, a solid object, that would be beta. And then down here, we're going to complete nuclear equations. So I kind of darkened in the numbers so they were easier to see in case you had a hard time on your study guide. But for the first one, we have potassium with a mass of 42 and an atomic number of 19 that is going to release a beta particle. So as I said, when that happens, within the nucleus of this potassium, a neutron is splitting into a proton and an electron. So that electron comes out right here, which means the proton stayed behind because it's not listed on the right side of the arrow. So if the proton stays behind, that's going to make our atomic number go up by 1. But our mass number has to stay the same because all we did was trade a neutron for a proton. They have the same mass. So to finish our equation, we're going to have 20 as our new mass number, and 42, our mass is going to stay the same, and number 20 on the periodic table is calcium. And then here, we have beryllium with a mass of 9, atomic number of 4. Nothing changes about it, not even the atomic number. So that means you have to have gamma radiation for that one. Down here we have an alpha decay, and with an alpha decay you have the loss of 2 protons and 2 neutrons. So if we lose 2 protons from our atomic number, which is 3, that's going to leave us with an atomic number of 1. And then if we're going to lose 2 protons and 2 neutrons, that means our mass number has to go down by 4. So our new atomic number would have to be 2, or excuse me, our new atomic number would have to be 1, and our new mass number would have to be 2, which means that our new element formed is going to be hydrogen. And over here, we have a couple of alpha decays, so just you can see that nothing has changed. We still have a decrease of 4 in our mass number and a decrease of 2 in our atomic number both times. And then we're using the figure, we're supposed to tell how many alpha particles are produced as uranium-238 decays to lead-206. And you could use the picture and go through the numbers, and every time you see a decrease of 4, you would have lost an alpha particle, or you can just use the fact that they're printed on there. Every time you see an alpha symbol through the process, you have an alpha decay. So all I did was count those up, use what you're given, that's what I say. So 8 alpha particles are produced in that decay. And then how many beta particles? Again, I just counted them up every time I saw them. Like here's one right here, here's one right here, for a total of 6. And then down here on number 9, write an equation showing that when protactinium-229 goes through 2 alpha decays, francium-221 is formed. So I did my first alpha decay, I even labeled it number 1. So I took my protactinium, lost an alpha particle, which means 2 protons, so I go down to 89, and then 2 protons and 2 neutrons takes my mass number down by 4. And then my second alpha decay is going to begin with the daughter particle here, so I just move this down. And again, we have a loss of an alpha, so down 2 for our atomic number, down 4 for our mass number, which gives us francium. So writing the nuclear equation for the decay of polonium-210, if it undergoes 2 alpha decays, then a beta, and then another alpha. So I just went ahead and labeled them 1 through 4, so you could see the whole process that I went through. And I was tight, I didn't have much room, I need to do better on that next time. So you can see each as I progressed through. There's the first 2 alpha decays, and then I brought it down here for the beta, and then my final alpha decay here to wind up with this isotope of gold. And then 3 different uses for nuclear technology. Hopefully you guys knew this from your nuclear research assignment or the Google Slides assignment. But here are several. Agriculture, medical uses, space exploration, water desalination. And then number 12, the fuel used at nuclear power plants, they all use uranium-235 because it's easy to split. And then number 13, how and where is nuclear waste stored and disposed of in this country? This was the question that the most people missed on that nuclear research assignment, because a lot of you said that we put it in Yucca Mountain. We don't. That was an idea that was proposed in the 80s, and it has never officially been opened for use. It is still kind of in the debate stages. So all we're able to do with our nuclear waste right now is when it first comes out of the reactor, it's stored in pools to cool, and then they move it to those above ground steel and cement casks, and they all pretty much stay on the property of the power plant that they come out of. And then how does nuclear power work? A quick summary. I'm sure you guys could do better than this with your description, but this is just a quick summary that I went through. You have a nuclear reaction that produces an extreme amount of heat, which boils water to produce steam. The steam turns the turbines and then powers the generator. And then the 3 major nuclear accidents that we talked about were 3 Mile Island, Fukushima, and Chernobyl. And then on this part right here, I am not going to write essays for you, but I did give you the 3 that are possible on the test in advance so that you could prepare your answers ahead of time and be studying those as we go. So make sure that you are doing that because any one of those 3 could be on the test. So now we're using a decay chain of uranium-238 in the figure, and then it's asking what the final product was. So if I look at the decay chain, arrows are moving down this way, so I know I started from here. Uranium-238 is the mass number. It tells me it's where it started in my question. So then we go down through these processes. The final product is going to be lead, and then its mass number is 206, so you have to identify that specific isotope. So the final product would be lead-206. Now in question B, using the figure, you're going to list in order each type of decay that occurs all the way down to lead-206. So it's pretty easy if you just read this like a graph. You have mass numbers on the side and atomic numbers on the bottom. So every time your arrow moves down, you have a change in mass number. The only time that can happen is an alpha decay because it doesn't happen in beta and it doesn't happen in gamma. So that's an alpha decay every time your arrow moves down. And then in the case of this one where it's moving to the right, our atomic number is increasing. You can see it. It goes from 89 to 90 to 91, 92. So every time you increase an atomic number by 1, which you can see this is increasing by 1 every time you move to the right, it has to be a beta decay. If it was alpha, it'd be moving 2 spaces to the right and down. So every time you move to the right, it has to be beta. Every time you change mass number, it has to be alpha. And if you go through those, you will see that this is the order that they're talking about. So before you go, I just want to encourage you to please study hard. No, you will not be allowed to use notes on this test. We are taking it in class, so this is going to be like a real test. This is the best way to raise your grade. Tests are worth 40% of your grade. So if perhaps your first test didn't go how you'd hoped, now is your chance to raise that grade. So please study hard and do well. Remember that parent-teacher conferences are next week. Just as a reminder. Good luck. Ask me as many questions as you need. I'm here for you.